Hello, everyone. Welcome back to the course on time and space complexity analysis. I am Sanket Singh, and in this lecture, we are going to continue our discussion on problem solving around calculation of worst case complexity of different algorithms. In this playlist, we have already completed that why efficiency of algorithm is important, how do you measure the algorithm with respect to hardware, and how a single CPU core system works. We already talked about rate of growth and asymptotic analysis. And even in the last lecture, I already talked about a few problems and how you can calculate the big O notation based worst case complexity for them. In this lecture also, we are going to solve around 3 4 more questions, which are going to give you better clarity that when you actually see an algorithm, how you should move forward to calculate the complexity for it. In my opinion, understanding how complexity of algorithm is calculated gets more clear when you solve more questions or you see more algorithms and try to calculate complexity for them. It's not a one time process. You need to be iterative in that. And this playlist is going to focus on that. We are going to solve a lot of questions where we will be calculating the time complexity of different algorithms. This lecture is going to be part of a bigger playlist that we are building for time and space complexity analysis to make sure that you guys get a good grip on this particular topic. So, without any further delay, let's just start and let's start solving our first question. So now we have this new function in front of us. First of all, without going very deep into the analysis, let's first see some normal observations. This time you have a nested loop. This time you have a nested loop. That is, there is an outer loop. This is the outer loop. And this is the inner loop. And can you see that it's not like first the outer loop will be completed, then the inner loop will go. No. Outer loop and inner loop are very tightly coupled. With one iteration of the outer loop, the whole inner loop executes. Then with the next iteration of the outer loop, the whole inner loop executes, and so on. Right? So we have to figure out things in a much more graceful way. Okay. Now if I just carefully see, when there were like single loops, I just used to see from 1 to log n it goes, so order of log n. This one goes from 1 to n, then sorry 0 to n minus 1 and 0 to m minus 1. So it is n plus m. This one used to go from 0 to n minus 1, so this is order of n. But this time, what happens is, outer loop goes from 0 to n minus 1, and then inner loop goes from 0 to n minus 1. And then inside the inner loop, you have an instruction, right? So let's see what happens. Let's see what happens. So this is the input. Whatever is the input, like n is 10, n is 100, n is 1000, doesn't matter. This answer variable will be initialized only once. That is constant time, right? Then inside the for loop, you initialize a variable I that is going to be constant time again, so c plus c. And then when I is 1, I is 0, initially I is 0. Then let's see how many instructions we are executing when I is 0. When I is 0, you compare, then you go and execute this for loop. Can I say that? So one instruction for comparison, and then this for loop. How much time a for loop like this, or how much instruction a for loop like this takes? We have already calculated that how much time a for loop like this takes. It approximately takes n unit of time, right? So can I say this for loop will take a constant c plus 1 2 3 3 nc instructions, which is approximately n instructions only. So there will be n for loop instructions, right? After the for loop is done, then you increment I. So 1 will be for increment. So can I say when I is equals to 0, then approximately you do n plus 2. What is n plus 2? Can I say approximately n iterations only? If n is like 10 raised to the power 6, then 10 raised to the power 6 plus 2 is nothing, right? So simple thing. When I is 0, you execute n instructions. Then I becomes 1. You again execute n instructions. then I becomes 2. You again execute n instructions, and so on. I becomes n minus 1. You again execute n instructions, and that's it. So in every iteration, you execute n instructions. How many total iterations are there? From 0 to n minus 1, there are total n iterations. There are total n iteration. In every iteration, you execute n instructions. So total instruction is what? N into n. One instruction takes c unit of time. So n into n instruction take n into n into c unit of time. So can I say my time complexity is what? N square c plus 2c. This is what? A lower degree term. This c is what? A constant. So the time complexity is what? Order of n square. That means the growth rate of this function is comparable to a quadratic function rate growth. That is, if n is 1, the loop, this function f3 will approximately take one instruction. Approximately, like 1 plus 2, like there can be something 1, 2, or 3. But when n becomes 2, it approximately takes 4 instruction. When n becomes 3, it approximately takes 9 instruction. When n becomes 4, it approximately takes 16 instruction. So you can see the rate of growth of time, or the time is measured by instructions. So the rate of growth of instruction is increasing quadratically, not linearly. Previous questions were it was increasing linearly, but this time it will be incrementing quadratically, and hence its order of n square. You can even add this last c. This is a constant c. So you can even add that, but again, at last also everything is going to get washed out because it's a lower degree term. So that's why when we will be solving harder questions, no, these type of statements, so we are going to just avoid. We're going to see only those statements which are dependent on input, because any statement which is not dependent on the input, we don't care about it, because that's not going to increase with the increase in input or decrease with the decrease in input. This is something that you have to keep in your mind. The answer for this function is going to be order of n square. I hope the overall logic of the problem is clear to everyone. Now we have another new function in front of us. This one is quite interesting. It takes an input n. It has a few constant instruction. I'm not going to now consider constant instruction. I'm going to only consider those instructions which are dependent on n. So this nested for loop looks like dependent on the given input n. Okay, cool. Now this outer loop, this outer loop, it starts from I is equals to 0 and goes till n minus 1. So it starts with I equals to 0, then I goes to 1, then I goes to 2, I goes to 3, I goes to 4, so on and so forth. I goes to n minus 1, right? And then the inner loop, the inner loop. Let's see. When I is equals to 0, can you see the inner loop is j equals to 0, j less than 0, j plus plus. So j starts with 0. Is 0 less than 0? Is 0 less than 0? No. So this for loop technically never executes because this statement is not true. So when I is equals to 0, there are no instructions executed from the for loop of j. Can I say that? See, when I is 0, j starts from 0. Is 0 less than 0? No. That means the inner for loop will never execute. And we go ahead and goes to I equal to 1. When I becomes 1, j starts from 0. Is 0 less than 1? Yes, it is. 0 is less than 1. So one instruction we will execute, or one iteration we will execute. In one iteration, you did the comparison, you add, then you increment. So let's see. When I is equals to 1, j starts from 0, right? You check. Is 0 less than 1? Yes. So one instruction. Then you add one more instruction. Then you increment one more instruction. So when j goes to from 0 to 1, it takes 3 instructions. Now, is 1 less than 1? Because j, the value of j is 1, value of I is 1. Is 1 less than 1? No. And this for loop will terminate. So how many iterations you did? You did only one iteration of j. When I is equals to 1, you did only one iteration of j. In one iteration, you had 3 instructions, right? So we can say we had total 3 instructions. looks cool. When I is 2, then I becomes 2. Then you go, I becomes 2. When I is 2, j again starts with 0, right? Then is 0 less than 2? Yes, it is. So you will execute this for loop once and j becomes 1. Is 1 less than 2? Yes. You execute this whole for loop again and goes to 2. Is 2 less than 2? No. So how many iterations you did? One iteration to go from 0 to 1, one iteration to go from 1 to 2. So total 2 iterations. Total 2 iteration. And in every iteration you do comparison, addition, increment. 3 operation. So you can say total 2 into 3, that is 6 instructions you are executing. Here executing 6 instructions. Right. Similarly for I is equals to 3, what you are going to do? When I will be 3, there will be how many iterations? You are going to go from 0 to less than 3. That is total 3 iteration. That is 0 to 1, 1 to 2, 2 to 3. There are 3 iterations. In every iteration, 3 instructions. So 3 into 3 is 9. This will be 3 into 4, 12, and so on. This will be 3 into n minus 1. Can I say that? And then how many total number of instructions do we have? How many total number of instructions now we are executing? So what we do, when I is 0, j never executes. When I is 1, j goes for one iteration and total 3 instructions. When I is 2, j goes for 2 iterations, and in every iteration there are 3 instructions, so total 6 instructions. When I is 3, j goes for 3 iterations, and in every iteration there are 3 instructions, so there are total 9 instructions. How many total instructions are there? Can I say? We can just sum them up. We can say 0 plus 3 plus 6 plus 9 plus 12, so on and so forth, 3 into n minus 1. We can take 3 common, 1 plus 2 plus 3 plus 4, so on and so forth, n minus 1. Right. This is what? Sum of the first n minus 1 natural numbers. Right. This is sum of the first n minus 1 natural numbers. What is the sum of first n minus 1 natural numbers? It is n into n minus 1 by 2 into 3. Right. Now just think about it. This 3 is a constant. This 1 by 2 is a constant. So you can avoid it. You are left with what? N into n minus 1, which can be written as n square minus n. N is a lower degree term. So you will avoid this one also. And can I say the time complexity will be what? Order of n square. Right. Order of n square. And technically you don't need to do this much amount of analysis. What you can just directly say is, when I is 0, j never executes. Then when I is 1, j executes once. And then in one iteration, there are 3 instructions. So technically you can say there is only 1. Then when I is 2, j executes 2 instructions. When I is 3, j executes 3 instructions. So technically we can write it as when I is 1, j executes I instructions, right? When I is 2, j again executes I instructions, and so on, right? So we can just sum up the total i's. So 1 plus 2 plus 3 up till n minus 1 is n into n minus 1 by 2, which is what? Order of n square. Because 1 by 2 will be avoided, n will be avoided, and hence. But when you are in your initial stages, this much analysis definitely helps. But later, whenever we will see, okay, outer loop is going from 0 to n minus 1, that is, outer loop is going n iterations. Inner loop is growing with n. So inner loop will give you 1 iteration, then 2 iteration, then 3, so on and so forth. So if you sum them up, it's approximately something like this. So whenever you see a loop like this, we can just directly infer the fact that the time complexity is order of n square. So I hope the overall complexity analysis is clear to everyone. So now this is a new function in front of you. This function takes an input n. It initializes a variable, that is technically this instruction is independent of the input n, Similar to this instruction is also independent of n. The only thing is dependent on n is this for loop. And we have seen similar for loops. If you just go back, if you just go back, the outer for loop was I less than n, inner for loop was j less than n. Our time complexity was n square. This time, outer for loop is 0 to n minus 1, that is total n instructions. Inner for loop is 0 to log n minus 1, that is log n instructions. So can I say, when I is 0, you execute log n instruction. When I is 1, you again execute log n instruction. When I is 2, you execute log n instruction, and so on. When I is n minus 1, you again execute log n instructions. So how many total number of iterations are there? Total n iteration. In every iteration, you have log n instructions. So one instruction takes a unit of time, but that's going to be constant. So this is going to be order of n log n, right? So see, every question that we are going to solve is going to be dependent on how many instructions you are going to execute. Sometimes in functions like this, you can just multiply the values of the bounds of the for loop. But like just like in the previous question, the bounds were not like directly given to us like n and then n, so n square. No. So this time you have to manually analyze how many instructions you are going to execute. You have to manually analyze. So sometimes manual analysis is going to help when the expressions are quite complex, but sometimes just direct multiplication can even help you, that this is going to be n into log n. So I hope the overall logic of the problem is clear to everyone. So now this is the new function f6 in front of us. It takes an input n, and we have to calculate the worst case time complexity. Now just think about it. This instruction is independent of n, so it just takes some constant unit of time, because this is just one instruction. One instruction takes some constant time. Similar to this, so we are just going to avoid them. Now these two for loops are dependent on the input n. Let's see. The first for loop, when the first for loop will be done, then only you will hop on to the next for loop. So let's focus first on the first for loop. The first for loop starts from 0, goes till n minus 1. So from 0 to n minus 1, can I say approximately in total, it will execute n iteration. In every iteration, there are 3 instructions, so 3n. Every instruction takes c unit of time, so 3nc is going to be what? Order of n. So the outer for loop is order of n. Or let's say the first for loop is order of n. Then you go inside this nested loop. If you see this nested loop, then we have already solved that what is the time complexity of this nested loop. If you just forget about rest of everything else, the complexity of this nested loop is what? Order of n square, right? And in a previous question, we have seen that if there is a for loop and after that for loop, we have another for loop. If let's say this for loop takes x instruction, this for loop takes y instruction, total instructions are x plus y. So here the value of x is n, y is n square. So can I say overall complexity will be n plus n square? And n is a lower degree term, so it will be avoided. So it becomes equal to order of n square. It becomes order of n square. So the time complexity of this function is order of n square, and that makes sense, because let's say if n goes to the range 10 raised per 5, this will become, this for loop will be taking 10 raised to the power 10 instructions, whereas this for loop will be taking 10 raised per 5. 10 raised per 5 is way less than 10 raised per 10. So the major additional factor that we have is order of n square. So that's what we do. We avoid all the type of constants, we avoid all the type of lower degree term, and then we get the final answer. So the answer for this particular function is going to be order of n square. Now this is the next function in front of us. This is a function f1. Looks like, right? I have written the syntax to be very verbose. This function takes two arguments, n and then m. Two arguments are there. Okay. What we have to do, we have to analyze the time complexity. And time complexity is what? Total time with respect to the input. This is the input, right? So with respect to the input, how the time is changing. And how do we calculate time? How do we calculate time? We calculate time as number of instructions executed. Total number of instructions. Total number of instructions we have to calculate. And we are going to take an assumption. Assume that one instruction takes c unit of time, where c is constant. right? C unit of time where C is constant. Okay, let's see. Now this is just an instruction to initialize a variable. So this is going to take C unit of time. This is just an instruction to print the answer. So C unit of time. Okay. So we can say C plus C is there. Then there are two for loops. Let's see the first for loop. Just think about it. When initially you will initialize this variable answer, then you will execute this for loop. Till the time you are executing this for loop, can I say very safely? Can I say very safely the fact that this for loop is not going to get executed till the time this for loop is still running? If this for loop is still running, this for loop is not going to get executed, right? Can I say that? So the second for loop will execute only after the first for loop is done. Let me even write it here. Second for loop starts if the first one ends. Second for loop starts if the first one ends. Okay, cool. Now let's see the first for loop. How many instructions are there in the first for loop? In the first for loop, you can see that you have initialized the variable. This variable initialization happen only once. So this is going to take C unit of time. So plus C. And then in every iteration, you compare, you add, you increment. So in every iteration, I do 3 instructions. You can say it like this: 3 instruction per iteration, right? So let's see. When I is equals to 0, you are going to use 3 instructions. What are the 3 instructions? When I is 0, you check is 0 less than n, then you add 1 to the answer, and then you do I plus plus, I becomes 1. So after 3 instruction, I becomes 1. Then again, is 1 less than n, you add 1 to it, and then I plus plus. So again 3 instructions, and you become I equals to 2. Then again 3 instructions, and so on and so forth. At last, the value of I will be equal to n minus 1. You do 3 instructions, and then the loop will end. So can you see total instructions will be equal to what? 3n. So here the time taken will be 3nc. Why 3n? Because in every iteration you have 3 instruction. Every iteration 3 instruction. And what is the total iterations? From 0 to n minus 1. How many iterations are there? Can I say n iterations? From 1 to n it is n iterations. Similarly from 0 to n minus 1 also it is n iterations, right? So if there are total n iterations, in one iteration you execute 3 instructions, then you see 3nc. So this for loop is contributing what? C plus 3nc. Now we will come to the next for loop. Here again you have a variable initializer that is going to take C amount of time. And similarly, in every iteration you compare, you add, you increment. So here also in every iteration you have 3 instructions per second. So how many iterations do you have? You have j equals to 0, you have 3 iterations, which leads to j is equals to 1, again 3 iteration, which leads to j is equals to 2, again 3 iteration, so on and so forth. J is going to end at m minus 1, right? When j becomes m minus 1, you execute 3 iterations and that's it. So total iterations is m. In every iteration you have 3 instructions. One instruction takes C unit of time. So total m iterations. Every iteration has 3 instructions. So total 3m instructions, and one instruction takes C unit of time. So 3m instruction takes 3m C unit of time, and that's it. So now the overall total number of instructions we got is 3nc plus 3mc plus 4c. Now just think about it. This 4c term is what? A lower degree term, because the other terms were what? N raised to the power 1 and m raised to the power 1. This is technically either n raised to the power 0 or you can say m raised to the power 0. So it is a lower degree term. So we are going to avoid this. This is going to get avoided. Then here you can say it is equal to n plus m into 3c. Now just think about it. C is a constant, 3 is a constant. This is going to get avoided. So can I say the overall time complexity is going to be order of n plus m in the worst case. And just think about it, no? Just think about it. If I don't have to do this much piece of analysis, then what I will say, this is just whatever is the input. Let's say n is 10 raised to the power 5, m is 10 raised to the power 6. Doesn't matter. Answer will be only initialized once and printed once. So can I say these two statements, these two particular statements don't depend on the input. So they are constant, right? If there are some piece of instructions whose execution doesn't depend on n or m, then they are constant. But the for loops depend on the input, right? So how much time the for loop is going to take? For loop initializes something, that's so is constant, but the remaining instruction goes n times. Remaining instruction goes m times, and first these n instructions will be executed, then these m instructions will be executed. So you can directly define that, okay, there is a for loop of n iteration, after that there is a for loop of m iterations, total it is order of n plus m. Similarly, in the previous question, there was only one for loop of n iterations. Even if there is, like, let's say 4 instructions, so 4n is what? Order of n only. So that's how you have to do it. That's how you have to calculate what will be the number of iterations in every function. Based on that, you will calculate the time taken and calculate the worst case complexity, or whatever case complexity we want to talk about. We can calculate that. Best case and average case we are going to discuss later. Now, one important piece of information from this function f1. Now, in this function f1, we saw that the time complexity is order of n plus m, or O of n plus m. Now, sometimes there can be a case that n and m are considerable, like they are close to each other. Like n is also of the, like the constraints are something like this, that n can be also at max 10 raised per 6, m can be also at max 10 raised per 6. So both are comparable. That means both of them will be used in the expression. But let's say in some case, let's say n is 10 raised per 6, but m is at max 10 raised per 2. So I can say m is very less than n. So if m is very less than n, in order of n plus m, m becomes a lower degree term. M becomes a lower degree term, and hence this will evaluate to order of n only, because m is going to be avoided. So when I say order of n plus m, you have to keep in mind that n and m are considerable or comparable. Like 10 is per 6 and 10 is per 5, still comparable. But 10 raised to the power 6 and 10 is per 4, or 10 is per 2, or 10 is per 3, this is not comparable, right? So this thing we have to keep in mind.